Okay, so Year 8, Lesson 6, more on resistance. This is the last thing I really want to talk about resistance, and that's this. If you've got an electric circuit, and the electrons don't have any choices, so you know the current is going to be the same all the way around the circuit. This is what we said about put an ammeter here, and you put an ammeter here. Those two currents are going to read the same thing because it doesn't have a choice. But let's say we give it a choice. So let's say, okay, you could either take the orange route or you could take the blue route. Now, the example that we gave earlier, we said that these two routes were just as easy as each other. But let's make it. And if they're just as easy as each other, well then it will split 50-50. Half of it will go this way and half of it will go this way. But let's say I added another bulb in here. So this way is now twice as hard as this way. So the blue one is twice as hard as the orange one. Well, what happens is electrons, they're not silly, okay, and they are really lazy. So what they do is, let's say you had 9 amps in the circuit. What happens is that 6 amps will go this way and 3 amps will go this way. So because this way is twice as hard as this way, half as much current goes this way as this way. And let's say it was a 12-volt battery. Well, that doesn't change anything because we know that the voltage is still going to be 12 volts there, and we know there's going to be 12 volts there. But we know that these bulbs are going to be half as bright as this one because they've got to split that 12 volts across the two of them, whereas this one gets it all to itself. Now, we can work out what the resistance of this bulb is from this. So we would say that the resistance is 6 amps times 12. So, sorry, V equals IR. Remember we said that you could divide by I, so you get R equals V divided by I. So that equals 12 divided by 6. So that's then that R is equal to 2. And let's see if that's true when we do it for the next one. When we say that R is equal to 12 divided by 3 equals 4 ohms. So it works, and we can see that the resistance is twice as big on this one as this one. We did it with the maths and we did it in theory. So that is why half as much goes this way as goes this way. To keep that V equals IR correct. And it's because electrons aren't silly, but they are lazy. So they always pick the easiest route. So 2/3 go that way, 1/3 goes this way. Another example? Okay, let's see if we can do this one. If it's a rectangle, it's something called a resistor. Let's say that is a 100 ohm resistor. And then let's say we've got a 100 ohm resistor there. And we've got another 100 ohm resistor. And let's say we've got 3 lots of 100 ohm resistors on this one. And let's say that we put in 24 volts into here. Okay. So I know that the amount that's going through this one is going to be twice as big as this one, and it's going to be 3 times as big as this one. Okay. So I know that this one it's going to be twice as big as, I know this one it's going to be 1/3 bigger than this one, okay? So how do I do that? Well, I need two numbers, one of which is twice as big as the other, and then this one is 3 times smaller than this one. Okay, so that's 12 volts. Well, not 12 volts, sorry, 12 amps. Then what's it going to be? Give me a second to work it out. That's right. Okay, this one is half as big as this one. That one's going to be 6 amps. And this one is going to be 4 amps, which is 3 times smaller than this one. And if I put an ammeter in here and an ammeter in here, this one is going to read 12, add 6, add 4, so that one is going to read 22. And this one, they all come back together. So the 12 from that one, the 6 from that one, and the 4 from that one, they've all come back together, so it's going to read 22 amps here as well. So just remember, electrons are lazy. The easiest route will always have the most electrons going through it, and it splits on the same basis of how hard it is. So if it's twice as hard, you get half as many go through, so 3 amps as opposed to 6 amps.